Today we're going to learn how to solve square and cube root problems. You should be on pages 8 and 9 in your yellow notes packet. The first thing that I want you to do is pause this video and copy down all of these vocabulary words. A square root is one of two identical factors of a number. It's important to remember that every single number has two square roots. One is positive and one is negative. This is because if I say, for example, the square root of 25, well, the square root of 25 is the number that can be multiplied by itself to get 25. Well, I know that 5 can be multiplied by itself because 5 times 5 equals positive 25. But also, negative 5 is a square root of 25, and this is because negative 5 times negative 5 also equals positive 25. So each square root has both a positive and a negative solution. The radical is the sign that is used to find the square or cube root of a number, and it looks like this. When you just see a radical with no number, this indicates a square root. When you see a radical that has a 3 outside of it, this indicates a cube root. A perfect square is a number made by squaring a whole number. For example, 16 is a perfect square because 4 times 4 equals 16. Other examples of perfect squares are 36. So 36 is a perfect square. And we know that it is a perfect square because 6 times 6 equals 36. Another perfect square is 81. Well, we know that 81 is considered a perfect square because 9 times 9 equals 81. A cube root is a value that when cubed, which means multiplied by itself 3 times, gives the original number. Unlike a square root, a cube root only has one cube root, and that answer is either positive or negative. For example, if I found the cubed root of the number 8, well, that answer is 2, and this is because 2 times itself 3 times, so 2 times 2 times 2 gives us positive 8. The answer is not negative 2 because if we multiplied negative 2 times itself 3 times, negative 2 times negative 2 right here would give us positive 4. But then we would have to make sure we multiplied by this negative 2. Well, positive 4 times negative 2 is negative 8. Well, that means that negative 2 is not the cube root of positive 8. It would actually be the cubed root of negative 8. A perfect cube is a number made by cubing a whole number. So for example, 64 is a perfect cube because 4 times 4 times 4 equals 64. Another perfect cube would be 27. So we say that 27 is considered a perfect cube because if we multiply 3 by itself 3 times, so 3 times 3 times 3, we get 27. Another perfect cube is 125. Well, we would say that 125 is a perfect cube because 5 times 5 times 5 equals 125. Now, when we look at these, we can figure out the solution to these squared problems by just multiplying each of these by itself 2 times. Well, 1 squared really means 1 times 1, and so the solution to that would be 1. 2 squared means 2 times 2, and that solution is 4. 3 squared is 3 times 3, so the solution is 9. 4 squared is 4 times 4, so the solution is 16. 5 squared is 5 times 5, which is 25. 6 squared is 6 times 6, which is 36. 7 squared is 7 times 7, which gives us 49. 8 squared is 8 times 8, which gives us 64. 9 squared is 9 times 9, which gives us 81. 10 squared is 10 times 10, which gives us 100. 11 squared is 11 times 11, which gives us 121. 12 squared is 12 times 12, which gives us 144. 13 squared is 13 times 13, which gives us 169. 14 squared is 14 times 14, which gives us 196. And then 15 squared is 15 times 15, which gives us 225. Now, we can use this to find the answers to square root problems. If I see a problem that says this, the square root of 49, the problem is asking me what number or numbers can be multiplied by themselves to get 49. Well, remember, all square roots have a positive and negative solution, so they all have 2 solutions. One should be positive and one should be negative. So the square root of 49 is what number multiplies by itself to give me 49. Well, we know that 7 multiplies by itself to give me 49, so our solution is positive 7 and negative 7. And this is true because negative 7 times negative 7 gives us positive 49. The square root of 25 is 5 and negative 5 because 5 times 5 and negative 5 times negative 5 gives us 25. The square root of 36 is 6 and negative 6. The square root of 121 is 11 and negative 11. The square root of 4 is 2 and negative 2. The square root of 16 is 4 and negative 4. The square root of 169 is 13 and negative 13. The square root of 144 is 12 and negative 12. The square root of 81 is 9 and negative 9. The square root of 9 is 3 and negative 3. The square root of 1 is 1 and negative 1. The square root of 196 is 14 and negative 14. The square root of 64 is 8 and negative 8. The square root of 100 is 10 and negative 10. And finally, the square root of 225 is 15 and negative 15. Now let's look at cubes. Remember that a cube means that we multiply the number by itself 3 times. 1 cubed means 1 times 1 times 1. Well, that gives us 1. 2 cubed means 2 times 2 times 2, which gives us 8. 3 cubed means 3 times 3 times 3, which gives us 27. 4 cubed means 4 times 4 times 4, which gives us 64. 5 cubed means 5 times 5 times 5, which gives us 125. 6 cubed means 6 times 6 times 6, which gives us 216. 7 cubed means 7 times 7 times 7, which gives us 343. 8 cubed means 8 times 8 times 8, which gives us 512. 9 cubed means 9 times 9 times 9, which gives us 729. Finally, we have 10 cubed, which is 10 times 10 times 10, which gives us a value of 1,000. Again, we can use this to find the cubed root of numbers. Remember that unlike square roots, cube roots only have one solution. And that solution will either be positive if the number inside of the radical is positive, or that solution will be negative if the number inside the radical is negative. For the cube root of 216, I know that 6 cubed is 216, so the solution here is 6. For the cube root of 27, I know that 3 cubed is 27, so the cube root of 27 is 3. For the cubed root of 125, I know that my answer is 5. For the cubed root of 1, my answer is 1. For the cubed root of 8, my answer is 2. For the cubed root of 729, my answer is 9. The cubed root of 512 is 8. The cubed root of 1000 is 10. The cubed root of 343 is 7, and the cubed root of 64 is 4. Now, we can look at these and we can try to figure out where these would be located on a number line. These numbers are non-perfect cubes, or squares and cubes. These are numbers that do not have perfect whole numbers, so these would be irrational answers. But we can figure out about where they would be located on a number line by thinking about what we know about these. If we think about the square root of 18, on a number line, the square root of 18 would be between two perfect squares. Well, we know that the square root of 4, or the square root of 16, is 4. And we know that the square root of 25 is 5. That means that the square root of 18, because 18 is between 16 and 25, then on the number line, that would be somewhere between 4 and 5 on the number line. When I think about 18, I know that 18 is closer to 16 than it is to 25. So the square root of 18 is going to be closer to 4 than it is to 5. For the cubed root of 46, I want to think about perfect cubes that I know. Well, I know that we have the cubed root of 27, which is 3, and we have the cubed root of 64, which is 4. I know that 46 is somewhere in between 27 and 64, so it would be somewhere in between them on a number line. So I know that it is somewhere between 3 and 4 on my number line. Now, which one is it closest to? Well, I have to figure out how far 46 is away from each of those. When I think about 46 to 27, well, 46 is 19 spaces away from 27. And when I figure out 64 minus 46, they are 18 away. So that means really the cube root of 46 looks like it's pretty close to the middle of 3 and 4, but it is a little bit closer to 4. For the cubed root of 9, we need to find two perfect cubes that 9 would be in between. Well, I know that the cubed root of 8 is 2, and I know that the cubed root of 27 is 3. So when I look at 9, I know that 9 is in between 8 and 27. So on the number line, it would be located somewhere between 2 and 3. Well, I know that 9 is closer to 8 than it is to 27 because it's very close to that. That means that it's closer to 2 on the number line. For the square root of 83, we need to find two perfect squares that 83 would be in between. Well, we know that the square root of 81 is 9, and then we know that the square root of 100 is 10. So since 83 is between 81 and 100, I know that it is somewhere between 9 and 10 on a number line. But if I look at this, if I'm looking at 81 and 100, I know that 83 is closer to 81. And since the square root of 81 is 9, I know that this is closer to 9 on the number line than it is to 10. For the square root of 67, we again need to find two perfect squares that this would lie in between. Well, I know that the square root of 64 is 8, and I know that the square root of 81 is 9. So the square root of 67 is somewhere between the square root of 64 and the square root of 81. That means that it's located somewhere between 8 and 9 on the number line. Since 67 is closer to 64 than it is to 81, I know that 67 is going to be closer to 8 on the number line than it is to 9. For the cubed root of 150, we need to find two perfect cubes that this would be located in between. Well, if we think about this, we know that the cubed root of 125 is equal to 5. And then we know that the cubed root of 216 is equal to 6. Well, since 150 is in between 125 and 216, this tells us that it's going to be somewhere between 5 and 6 on the number line. Well, 150 is closer to 125 than it is to 216. This means that this would be located closer to 5 on the number line than it would be to 6.